Hi guys, myself Chandrapratap Reddy M from the Department of Electronics and Communication Engineering. Today we are discussing about lossless transmission lines and its applications in RF systems from the subject EM waves and transmission lines, lossless transmission lines and its applications in RF systems. Introduction to lossless transmission lines. Transmission lines are designed to have a negligible resistive losses. These lines primarily function to transmit high frequency signals with minimal degradation. Understanding their principles is crucial for efficient RF system design. Basics of transmission lines. A transmission line consists of conductors that carry electrical signals from one point to another point. The fundamental parameters of transmission lines include inductance, capacitance, resistance and conductance. Lossless transmission lines are characterized by their low resistance and conductance values. Characteristics of lossless transmission lines. Lossless transmission lines exhibit uniform voltage and current distribution along their length. They can be described by characteristic impedance, which is determined by their inductance and capacitance. The propagation constant in lossless lines consists only of a phase constant with no attenuation factor. The lossless transmission line wavelength is given by lambda equals to mu p by f, that equals to cf by 1 by square root of mu r, that equals to lambda naught by mu r, where epsilon r equals to relative permittivity. For the lossless line, there are two unknowns in these equations for total voltage and current on the line. V of z equals to V naught power V naught e power minus jp z minus V naught e power minus jp z. I of z equals to V naught by z e power minus jp naught jp z minus V power V by z e power minus jpz. Mathematical representation. The Telegraphers equation governing the behavior of transmission lines include lossless types. For lossless lines, the equations simplify, reflecting ideal conditions without resistive losses. This simplification allows for easier analysis and design of RF systems using these lines. Importance in RF systems. RF systems utilizes lossless transmission lines to maintain signal integrity over long distances. These lines minimize signal distortion, allowing for clear communication in wireless applications. Their use in essential in applications like antennas, filters and amplifiers. Applications in antenna field lines. Lossless transmission lines are commonly used as field fed lines for antennas in RF systems. They allow efficient power transfer from transmitters to antennas without significant loss. This efficiency enhances the overall performance of the antenna system. First one, coaxial cable fed. Second one, twisted pair fed. Third one, delta match. Fourth one, quarter wave matching transformer. Feeding antennas with resonant lines. These diagram shows feeding antennas with resonant lines. Used in RF components. Many RF components such as filters and duplexers benefit from lossless transmission lines. The use of these lines helps in preserving signal quality and bandwidth in RF circuits. This is particularly important in systems where multiple signals coexist in close frequency ranges. Here there is a diagram. The diagram shows that reconfigurable fifth order BPF and protograph of a BPF integration with microwave technology. Lossless transmission lines are integral to microwave technologies used in communication systems. There are utilized in waveguides, which are a type of transmission line for high frequency signals. Their characteristics enables the efficient transfer of microwave signals in various applications. Here, transmission line diagram is there. You have to know that microwave relay station, first one, second one main microwave, third one microwave relay station. This figure shows that microwave relay stations 8 of 40 to 50 feet spaced at least 20 to 30 miles apart. Signal propagation and phase shift. In lossless transmission lines, signal propagation occurs without energy loss, maintaining up amplitude. The phase shift introduced by the line is determined by its length and frequency of the signal. This property is exploited in RF systems for precise timing and synchronization. Here there is a diagram about lossless transmission line, characteristic impedance and SIL. Antinode nodes. Here high amplitude is a antinode and zero amplitude is a node. Impedance matching. Impedance matching is a crucial in RF systems to maximize power transfer and minimize reflections. Lossless transmission lines facilitate effective impedance matching through their characteristic impedance. Proper matching ensures that system operates efficiently and reduces signal loss. Applications in test equipment. Test equipment for RF measurements often employs lossless transmission lines for accuracy. These lines are minimize signal degradation using testing, leading to reliable measurements outcomes. Accurate characterization of RF components is essential for effective system design. Role in distributed amplifiers. Lossless transmission lines are key components in distributed amplifier designs. They help maintain the signal phase and amplitude across multiple amplification stages. This design approaches enhances the overall gain and bandwidth of the amplifier. In lossless transmission line, resistance and conductance are equals to 0. That means R equals to 0 and G equals to 0. Transmission line lossless. Impact on signal integrity. Signal integrity is critical in RF applications and lossless transmission lines plays a vital role. They help reduce signal distortion and crosstalk between different channels. Maintain integrity is essential for high performance RF communication. Here there is a diagram. We have to show that driver via PCB. Here signal flows from driver through PCB over plane and ground plane, receiver and DC power supply. And second diagram is original signal and deviated signal with transmission problems. Analysis tools for design. Various simulation tools can analyze the performance of lossless transmission lines. These tools allow engineers to model the behavior of RF systems before physical implementation. Accurate modeling is vital for optimizing system performance and reliability. Practical considerations. Despite their theoretical losslessness, real-world factor can introduce some losses. Ensuring proper installation and material selection can minimize these practical losses. Consideration of environmental factors is also important for system longevity. Future trends of in RF systems. The demand for higher frequencies and bandwidths is driving innovation in transmission line technology. Advances in material science may lead to improved lossless transmission line designs. Future RF systems will rely on these advancements to meet increasing performance demands. In the year of 2023, emerging AI and machine learning tools. First one generative AI, second one overlap of AI and IoT, third one augmented intelligence, fourth one transparency, fifth one composite AI, sixth one algorithm decision making, seventh one no code tools, eighth one cognitive analytics, ninth one virtual assignments, 10th one wearable devices, 11th one data security and regulations, 12th one natural language and processing. Case studies in RF applications. Several case studies highlight the successful implementation of lossless transmission lines in RF systems. These real-world examples demonstrate the benefits of using these lines in various applications. Learning from case studies can guide future designs and innovations in RF technology. Here there is a diagram about resource allocation manager. This can be divided into three: digital receivers, signal and data processing, digital waveform generators. In digital receivers, receive array and communication, and also ES and radar. Signal processing, there is no signal processing and data processing, there is no differentiation. And digital waveform generators, there is a radar EA and radar transmitter. Conclusion: lossless transmission lines are essential for efficient RF system design and operation. There is a unique characteristics enable high frequency signal transmission with minimal loss. Understanding and utilizing these lines can significantly enhance the performance of RF applications. Thank you.